Here, we are given with two basic logical operators, the negation and the disjunction. It is up for us which of the two we'll be considering first for our truth table. Our truth table, as mentioned, would have the number of rows determined using this formula, 2 to the power of n, where n would be the number of propositions declared on our logical statement. Since we have propositions p and q, that would mean we only have 2 for our n, 2 squared, and this gives us 4. This 4 tells us the number of rows we need to add for our table, excluding the header. The header should include the proposition p and the proposition q, and then the rest of the necessary applications of our logical operators later. Of course, we are going to come up here, as mentioned, 4 rows. So we have 1, 2, 3, and we have 4. Okay, if you're going to add this one, don't worry about adding that. That's just the header. So for our p and q, we need to consider the possible truth values for each proposition. For our proposition p to be paired with proposition q, we can start here with t, or true, and another true here. There are two true propositions or assumptions because this will be paired with another true truth value for our proposition q and the false proposition q. To complete, our next would have two false propositions. This will be paired again for our proposition q, we having true and false. Now, looking back on our given, we have two logical operator, the negation and the disjunction. We are going to start with a disjunction because it is under a grouping symbol. Hence, we'll be adding that column here pertaining to p or q before we apply the negation for our logical statement. So as mentioned, this still has 4 rows. Now, for disjunction, the resulting truth value of that would depend on the concept that there should be at least one of the two propositions to be true. If we only have at least one, automatically the resulting disjunction is automatically true. Now, for our first, we have here true and true for our p and q propositions. So there are two true propositions. Hence, here, this is true because you only need at least one. Looking to the next row, we have 1 true and 1 false. This still fall on the idea of having at least one true proposition. Hence, for the disjunction here, we also have true. For our third row, false and true propositions. So regardless of being proposition P being false proposition, since our proposition Q is true, the resulting disjunction of both is also true. And finally, for our last row, false and false, since there is no true proposition, automatically the result is false. Now, we are not yet done because the entire logical statement is the negation of the disjunction. So adding another column here and labeling its header, negation of the disjunction of P and Q. We still have 4 possibilities here, and we just simply apply to this column the idea of the negation. The negation is simply reversing the truth value of the given proposition or results of proposition under the grouping symbol. Since the given proposition was actually disjunction of P and Q, and we're taking its negation, so we are going to reverse the truth value for each row. Since the truth value for the first situation for disjunction of P and Q is true, its negation is false. For the second row, since this is true, this is also false. The third, this is true, so this is still false. And for the last one, since the fourth result of our disjunction with propositions P and Q is false, its reverse is true. This completes the truth table for the negation of the disjunction of propositions P and Q. Don't forget to like and share our videos, leave a comment, and reasonably subscribe to our channel.